Hello everyone, and welcome to this meeting of the working group on contributing MicroJIT to the OpenJ9 project. Today is January 14, 2021. For today, I have no formal agenda, so let's play it by ear. Now, I know that has some topic to discuss, so Scott, why don't you start?
Perfect. Thank you, Marius. So while I'm currently going through the JIT profiling things, I'm also getting together my PhD proposal, and as part of that, I'm looking into other things that we can do with MicroJIT, both to it and in how we use it. Earlier in, I believe it was in the PR, there was a comment asking if there was any plans to have MicroJIT be aware of some of the other methods of compilation and limits on compilation. And one of the things that was brought up there was JIT server. And the more I thought about it, the more I realized that JIT server and MicroJIT are both kind of trying to do the same thing, reduce warm-up time in resource-constrained situations. So MicroJIT, in the paper that we published in Cascon, we showed that it was a viable alternative to TR when you had very resource-constrained systems. And JIT server takes TR and tries to move it to a central place so that a bunch of different nodes can use one compilation node. So I'm thinking about, as part of my PhD, extending MicroJIT to be aware of JIT server, but not run on JIT server. The nodes themselves are already resource constrained, which is a good use case for MicroJIT. The threshold for compilation is still going to be based off of method invocation and how often methods have been invoked. MicroJIT causing methods to get invoked more frequently by speeding up how long it takes, or reducing how long it takes to execute a method, is still the main means by which it reduces warm-up time. And the main disadvantages of JIT server are that the communication is happening over the network. And the main advantage is that it takes all that load and puts it in a single place. MicroJIT's already fast to compile and uses very few resources, so you're not getting much of a benefit by pooling all the compilations for MicroJIT in one place.
Right.
And the other thing is that the main penalty of JIT server being network communication, the actual body of the methods that are compiled by MicroJIT are often substantially larger than TRs because we're using templates and we don't do any of the optimizations. So one of the things I want to eventually look into is having the compiler aware of JIT server without necessarily always sending the requests to JIT server. So the compilations for basically the idea that we could have MicroJIT working on the clients of the JIT server, while the JIT server still serves compilation requests that would usually go to TR. And then compare that with how things would work if we did just get MicroJIT working on JIT server, and if we didn't have a JIT server and just used MicroJIT. And try to compare both like the threshold or the throughput, like what is our eventual maximum throughput or our stable throughput, and how quickly do we get there.
Yeah.
And in order to do that, I need to learn more about JIT server. So I'm hoping to learn today a little bit about what does JIT server, or not what, but how does JIT server intercept compilations? How does it change the control flow of a request for compilation? And how do you, as a client, learn that a method you need compiled has already been compiled? Does it happen at the same threshold? Those kinds of questions. Or is there a preemptive thing sent out to say, hey, that method's compiled, and we'll send it when you need it next?
Okay. So I think you should include not only G-server but also AOT in this comparison. So you have, let's say, three I shouldn't say competing. They are somehow competing, but also complementary. So there are three techniques. So it's AOT technology, it's G-server technology, and MicroJIT. More or less, they try to do the same thing, and they try to, lower the overhead or hide the overhead from compilation, be it memory or CPU. So let's talk about each one. So AOT technology. So it's very good where it can be applied. But now not all methods can be AOT'd. Not all classes are eligible for being put into the shared class cache. So you need to have your class loader extend the URL class loader or teach that class loader about the presence of the shared class cache. Another disadvantage of AOT is that peak performance is about 10% off today compared to a regular JIT compilation. And yet another downside, if you want to count like that, is that it needs a cold run. So cold runs are going to be slow. Now, going back to G-server, G-server can be a complementary mechanism to AOT. Because it can compile methods that cannot be AOT'd, and it can top up the performance through recompilation. It also can help with cold runs, right? Because those are going to be expensive. Now, coming back to MicroJIT, so I see that MicroJIT competes more or less with AOT because they try to do the same thing. And if for a method you can do both AOT and MicroJIT, I think that AOT is going to be a winner. I think it's the overhead of loading an AOT body is going to be lower than a MicroJIT body. But again, as I said previously, not all methods can be AOT, so MicroJIT can help with that. And it can also help with the cold runs, where AOT definitely has a big penalty. So yeah, our initial idea was right, at least I'm not sure if that was the initial idea, but I can envision a scenario where in order to cope with the cold runs, you could have the first time compilation done with MicroJIT. And in parallel with this, you can trigger an AOT compilation, which is going to be stored into a shared class cache. And in the next run, you can do a load from that. So definitely MicroJIT can help with the overhead of the cold runs. Now, about the interaction between MicroJIT and JIT server. Again, I see them helping one another. So MicroJIT being more like AOT, meaning that the quality is not there, but it's faster. You could start with compiling a method with MicroJIT as opposed to AOT, let's say, and then top up the performance of that MicroJIT code through a compilation that is done at the server itself in order to eliminate the overhead of that compilation. So the same way JIT server can help AOT, the JIT server can help MicroJIT. I'm not sure if I was clear about that.
It's like, so the way it sounds to me from that is basically that so a little bit on the AOT side, we had there was a paper where someone in J9 before it was OpenJ9, Federico Seguero took the JIT that was also called MicroJIT from the mobile version of Java 6 J9 and ported it to Java 8 J9. And in that paper, he compared MicroJIT to AOT, and he basically declared AOT always wins this fight whenever you have an AOT. My understanding of the compiler in OpenJ9 and how it uses AOT in the shared class cache is that the decision to load happens fairly early in the process, long before the call to compile. Is that wrong?
It's not a decision happens there. It is assumed that if you have an AOT body into the shared class cache, it is going to be loaded. And based on that, we set a lower count to methods that have an AOT body into the shared class cache. But the actual decision is actually when you need to compile it. But again, as I said, the decision is going to be use it. If you have it, use it. There is no downside of using an AOT body.
Okay, so a little more of a clarification about what I was asking a little bit. In the control flow for when something needs to be compiled, when it first hits that threshold, there's a bunch of things that get called, both for synchronous and asynchronous compilations. But where MicroJIT currently hooks in is at the end of the wrapped compile method. We have some checks to see whether something should be compiled with MicroJIT or with TR. And the way that TR was compiling, and we didn't change the name of any of that those things, was a call to a method that was called compile. And the object was the, hold on, I will pull up the name of the object that is.
Okay. So if currently it doesn't happen, so all those decisions need to be done more or less at the same place. And I believe that the first decision is whether or not we have an AOT body in the shared class cache. And if it is, we should load it because that is the fastest way of getting the method from interpretation to JIT code.
So that's basically what I'm asking about is right now, when does that check occur in the control flow? Because I'm wondering if right now MicroJIT's already working with AOT, and that if there is an AOT thing, does the AOT thing get loaded before you ever get to the point where
Okay, so I'll check this specifically for you, but this is the normal that we should do the check. So first AOT, and then MicroJIT, and then JIT server.
Okay, so I believe right now the way we have structured it, which obviously needs to change, is that right at the last second, basically, we just determine whether it should be compiled with MicroJIT, and then we swap MicroJIT in for TR. So right now the MicroJIT decision is after JIT server. So if JIT server is currently working with AOT, then we're already far enough down the line that we're already working fine with AOT. Because the entire idea of MicroJIT just doesn't jump into compilation.
And the answer is yes. So right now, I'm absolutely sure that if there is AOT there, we will load the AOT and we will not do a JIT server compilation.
Okay, so the next thing to do then would be to move the decision about whether something should be compiled with MicroJIT or not further up.
Before a JIT server check.
Yeah, and that may require an extensive review on my part of where the checks are for JIT server.
Yeah, I can definitely help with that.
Yeah. I also need to know exactly what happens once we determine that something needs to be compiled with JIT server, because some of the things that we're using in MicroJIT, or rather most of the things we're using in MicroJIT, as in terms of metadata, has all been set up by the compilation object and all of those things beforehand. And I want to make sure that I don't move the call to compile something for MicroJIT somewhere, end up copying a bunch of code to try and just staple it in to make it work, and then have two very similar but very distant in terms of starting point code paths when we could do something cleaner and easier to maintain.
Okay. So I do have access. Oh, you have the PR. So I can access the MicroJIT code from the PR, see where you hooked the decision to compile the MicroJIT, and I'll let you know if that needs to be moved up and down. Up or down. Okay, I'll put that as a to-do, and I'll let you know exactly where you can put your code.
I can give you a little bit of a hint in that it's at almost right before the line store hints in the SCC.
Okay.
Which I imagine is the shared class cache.
Yeah.
So right before that, there's a section where you would check the compiler hotness, make sure that it's not unknown hotness, and then you would make the call to compile that returns metadata. In there is where we hook in the stuff for should you compile with MicroJIT, and if so, we compile with that MicroJIT instead of that compile and get the metadata from there.
Okay, so I took that as a to-do. You'll have an answer by Friday, tomorrow.
Oh, awesome. Thank you very much, Marius.
No problem. Okay, is this the only topic, or you wanted to talk about J-profiling as well?
That's the only topic for right now. I had to put the J-profiling thing on the back burner while on the academic side I compiled my PhD proposal together. I've been putting that off for a bit and needed to get that done. That's done now, so I'll be back on J-profiling and hopefully have the first bit of stuff for the J-profiling paper, the data collection that we want to do, done soon. And then the next thing to do after that will be implementing the code generation for the optimizer with templates so that we can just call the same optimizer with MicroJIT.
Okay, that's good. Let's change topics then. Harpreet, I think I heard you yesterday saying that you may have some questions for Dara, so this is a good moment to interject.
Okay, thank you. Let me update everyone about my progress in the linkage refactoring. So I finally have my Win32 OpenJ9 build running on the Windows workstation. The document shared by Daryl was very useful in this respect, and a special thanks to Cheng for his quick replies for all the queries which I had all the way through. So with all that help, I now finally have the OpenJ9 running on the 32-bit platform, which is required for testing the linkage changes for the 32-bit. So we already tested it for the 64-bit, but now my next plan of action would be to test those changes for the 32-bit, which is a pre-requirement for the merging of our PR, which is currently open in the OMR. So for that, I would be using our own test framework. We have a test suite, which is used to compile the methods. Earlier, it was used to compile the methods using the MicroJIT, but now we have extended that test framework so that we can test the methods without MicroJIT, that is with the default TR as well. So for next couple of days, I would be using that test framework for testing the linkage changes. If for any reason that does not work, I would be exploring the test repository of the OpenJ9 as well as the FV test in the OMR. Currently, that is not running because it needs certain prerequisites to be installed before it can work. So my only question for today is, if at all I have some problem in like making them work, the FV test framework in the OMR and the test repository in the OpenJ9. So who is the correct person to contact in that case?
So is the question if you don't know how to use the testing framework, or what happens if you use it and something breaks with your code?
No, it's more or less the former part, that is how to use that.
So I believe that we have documentation on how to test OpenJ9. I'm not sure if your requirements go beyond that. And
I started with that, and for the Windows framework, it was like it was requiring certain prerequisites, and like
okay, yeah. I have no experience with Windows, or at least with testing with Windows. So all my testing is done on Linux.
Yeah, that is the actual part. Like when I was building the Win32, you get a lot of documentation for the Linux framework, but there is very little support for the Windows. That is why building the OpenJ9 on Win32 took a lot of time, and I have a lot of learnings from that, which I would be sharing as an contribution in the OpenJ9. But like using those test frameworks on the Windows, there is very little documentation in the open. So that is the real problem.
Yeah, I think the other thing you're going to run into is that I don't think it's necessarily that you're running them on Windows. I think it might also be that you're running them on 32-bit as well, because if you're getting them from the open community, we don't really run those. The OpenJ9 ones don't really run on 32-bit platforms, if I'm not mistaken. So there might be some additional steps or incompatibilities that you might run into while going through those. But so can we just take a step back for a second? Can you just summarize again what state are you in? You've made changes to OMR to do some. Sorry, is the refactoring that you've done solely in OMR, or is it also in OpenJ9 as well, like to the private linkage?
Yeah, okay. So I just made the changes to the OMR linkage. To be more precise, I just separated the properties from the linkages and put them up in a separate file. And while that is available in an open PR, so I have also made some changes based on some review points by yourself. And now it has already been tested on the 64-bit, but now I'm yet to test it for the 32-bit. So it's just the changes in the OMR, but I have to test both the OMR and OpenJ9 for obvious reasons.
Right. So, I mean, I'm just wondering if running it just a few sniff tests with a 32-bit build might be sufficient, because I mean, you can try setting up the testing framework, but I think that if you start to go down a very dark rabbit hole there, you may not want to go all the way down. You might perhaps just, if you find that the setting that up isn't that straightforward, or maybe even impossible, given the way that it's been architected, maybe just doing some sniff testing outside of the framework, running some Java applications in that might be sufficient to give us a good feeling as to whether or not something is broken on 32-bit Windows.
Okay, so what I take from this your answer is that I probably would be using our test framework. Like it has a lot of test cases which we run, and then we check whether the things are broken or not. That is working perfectly for the MicroJIT, like when we enable the MicroJIT option. So I would be testing the linkage changes by running the tests in the test framework by disabling the MicroJIT. That is, we enforce the methods to be compiled using the TR. So, okay, so that would be sufficient.
But let's give our testing a shot as well. If things break, they break, but maybe they won't.
Yeah, I mean, I try to set things up first, but I guess I'm just worried that you'll be spending a lot of time just trying to get our testing infrastructure working with 32-bit Windows when maybe it hasn't really been designed to work with 32-bit Windows. So I'd rather you not spend your time trying to get that to work there. But like Mary said, give it a shot. And if it doesn't work, then we'll go on to just some sniff testing.
Right. Okay. So those are some good pointers for me. Thank you. So that's it from me.
Okay. Thank you, Harpreet. Any other business? Any other topics to discuss?
I don't have any further questions. But if there's any questions that any of you guys from IBM have about MicroJIT and how it's progressing right now and where we're going with it, I'd love to field any of them.
Okay, if you offered, why don't you say a few words? Not too long.
So right now, the current plan is to basically split up the MicroJIT project until we get more students kind of in two. So Harpreet's looking more into how we can generify MicroJIT on kind of like two planes. One is to have it support more architectures. So the first step in that is getting the linkage thing working. Then making the linkage abstract enough that we can swap out the architecture for a different one. Then swap out the code generator for an equivalent code generator on another architecture and see if we can get it working on another device. And the other was in a language sense. Could we generify MicroJIT so that the input is not necessarily Java bytecodes, which is a much more difficult thing to do if you're not using an IL. It begs the question of how do you generify the input to a compiler if you don't have an intermediary form? And the other side of it is how can we improve MicroJIT to make it better at what it's meant to do, which is what I'm taking on. So the first thing that I'm looking at is reducing the negative impact on throughput through enabling the JIT profiling and trying to minimize the impact that has on our main metric of warm-up by making it do that efficiently. So good counter placement. On the side of JIT server, since JIT server is a thing that's trying, and AOT are both things that try to do the same thing, reduce warm-up time and reduce the overhead of compilation. I'm trying to make it work nicely and easily with those other technologies. The AOT one seems to more or less take care of itself. So the interesting part there is making it work good with JIT server. And the final thing is, since the actual reduction in warm-up time is directly based off of how fast does MicroJIT code run and how long does it take to compile things with MicroJIT, I'm looking at what kind of optimizations can I introduce to MicroJIT that won't have a big impact on compile time, but may have a big impact on the quality of code. Things like people optimizations and removing loads, since MicroJIT is a stack-based kind of architecture in terms of what it does. It uses an operand stack. So if I can, match a store to a load, and then instead of popping the value off the stack when we store, just peeking the value from the stack and writing it into the local slot and keeping it there, and then just do the work above it. And then when the load happens, if nothing was overwrote the slot that the store came from, then we don't need to perform the load, that kind of thing.
Okay, thank you, Scott. Just for my curiosity, so improving bytecode coverage under which of these two categories falls? Is it generifying the MicroJIT or improving the MicroJIT?
So it kind of fits under both because generally speaking, the idea is that we do want to have some bytecodes left unimplemented in the short term so that when new students come to work on the project, they have a starting point where we can say, okay, so this is how MicroJIT is structured, and here's where we do bytecode templates. Here's the architecture. Try implementing some of these bytecodes as kind of like a first foot in the water to get involved on the project. But generally speaking, the idea is that we want to support, and we currently support over 70% of the bytecodes now, but we want to support all of the common things like invoke static, invoke virtual, invoke interface. Originally we were putting invoke dynamic off, but it sounds like if this thing gets completed anytime soon, where the changes to how invoke dynamic are being run, If that happens, invoke dynamic is going to look a lot more like calling another method, which might be compiled or not compiled. And in that case, invoke dynamic might have a much cleaner and easier thing to implement for MicroJIT. But that's yet to be seen.
That's true.
But the idea is basically we'd like to be able to support all of the really common bytecodes, and we have a table of them, of the ones that are unsupported that are currently barriers to compilation from Eric Coffin's work.
Yeah. The invokes are probably the most important that remain to be done.
Yeah, that was my thought as well, because we've got, I believe, all the math ones done. If we have all the invokes done and all the math ones done, we should be in a pretty good state. It's already getting to the point where when I'm testing specific methods, I really have to see if I can look at the output of compiles that were successful, that I actually have to start limiting what we're compiling, because there's methods that I didn't put, that I wasn't expecting to compile that just suddenly get compiled with MicroJIT and work. Because there's just a lot of methods, and sometimes they're small and short, and we cover the bytecodes. So I'm hoping that we'll soon be in a place where a lot of things are being compiled with MicroJIT, and it's just a couple of bytecodes that need to be completed. So bytecode coverage is not forgotten, but we also don't want to knock it completely out of the park, because at least from our side of things as students, there's not a lot of academic things that we can get out of implementing all the bytecodes. So if one person like myself or Harpreet did all the bytecodes over the next 3 months, that would be 3 months of development work, but most, if not all of it, would be unusable for further academic publications.
Right, though, you know, without being able to run more complicated benchmarks, you cannot publish papers. So
True.
in a way,
Yeah. Yeah, we want to be able to run enough of the Da Capo suite that we can at least start, using that as a thing that we benchmark with, and then show, here's how much we sped this up by, here's the percentage of methods we covered, and then we can make some reasonable inferences on what continued improvements to bytecode coverage will mean. And then we can kind of, as like a part of the background or part of a section on each paper, can talk about how many bytecodes we now support. We'll add a few bytecodes here or there as we go along. So the idea is not to abandon bytecode coverage, but not also not to prioritize it. We want to support all the things that we want to test, and then also add a few bytecodes every now and again, that we can get a little closer, with probably the invoke ones being the big one we want to get done. And the other big important one that would be nice to have done is all of the non-local stores and loads, the ability to get field, put field, get static, put static, in general, including references.
so my understanding, in terms of timeline, let's say that you are putting off the bytecode implementation, at least for the different calls. That means that you are not planning on writing a paper until that happens, because you'll not be able to evaluate it, or?
Yeah, I'm hoping to have the profiling. So the profiling work is a little easier to do without bytecode coverage. So I'm imagining profiling work and counter placement and a paper on that being something that can be done without necessarily the invoke bytecode coverage. But it'd be really hard to test the improvements and penalties of any optimization passes without those bytecodes.
Exactly.
That was kind of on my next thing to do after JIT profiling, and kind of in concert with JIT server. Have both of those things kind of going at the same time, because every improvement to optimizations is an improvement on what MicroJIT has to offer for JIT server. and JIT server working might be a thing that can be done like while something else is being tested. I can probably run two things at the same time there, at least in terms of a development branch.
Okay.
So yeah, basically it's kind of like bytecode coverage is on the back burner until profiling works, and then getting a base level of we can run, you know, X percentage of decapo in MicroJIT is something that kind of needs to happen before I can do anything paper-wise with JIT profile, or sorry, JIT server and evaluating optimizations.
Right. Okay, thanks, Scott.
Conversely, I would also say as part of Harpreet's work, moving to another architecture necessitates writing bytecode templates for that architecture. So it would be like if we were to move to say RISC-V, there'd be no templates for RISC-V because we don't have any written yet. So that restarts the bytecode coverage for that architecture and would also have to get to a similar state. But if we lean enough on generalizing or writing good documentation around how we interact with the rest of OpenJ9, then at least the bookkeeping parts of that stuff, like the stack maps for references, those kind of things, should be already done by the time that Harpreet goes to do any of those templates. With respect to invoke virtual, invoke interface, and get field and put field.
Okay, thanks for the update. Anything else regarding any other business section? Okay, I'm taking that silence as a no. So our next meeting falls on January 28th. Are we good to go for that? I'm guessing yes. There's nothing.
Should be good for me. I can't think of anything that would interrupt that right now.
Okay, so
Good for me too.
good. So we'll make 2 weeks from now. So thank you everyone for attending. I will try to post the recording for this meeting. By the way, I don't think I have access to our YouTube channel to do postings. I know that Dan has. Maybe I can ask him. Daryl,
I can. I do.
Okay.
Yeah.
Then once I have the recording available, I will send it to you to post it because I don't have access. Sure. Or at least I think I don't. I never tried.
Sure. And you know what? Dan is actually pretty good at giving access. Like if you actually have a legitimate need for it, so if you just ask him, he'll give it to you. Because Andrew did the same thing with Andrew, right? He needed access to upload these recordings, so he'll give it to you.
Okay, then I'll ask Dan to give me access.
Okay, but if not, let me know. Yep.
Yeah. Okay, thank you everybody. I'll stop the recording now.
Bye.
Bye.
Perfect.